Okay, I think we can really start now. Okay, so hi everyone, welcome to this very hot webinar in July. Today we're going to talk about sessions you can trust. This is going to be the last part of the modern API testing series. Basically, what we're going to talk about is not really asserts and expects. Some of this are going to be like that, but most of it will be about building layers in different ways to create a suite of tests that we can trust. That's going to be that. So that's me. I'm Gil. Usually a lot cooler, but today's a hot day. I'm a trainer and a consultant, and I work with people who want to get better with what they do, being developers, testers, AI thingies, which we're going to discuss as well today. One of the things I'm going to talk about at the end is my new masterclass. Stay, you'll hear about it. But we're going to start with this. So I think a lot of people today, I know not all of them, but a lot of organizations are using AI all over their processes and coding. And that means there's a lot of code being generated by AI, and that means a lot of code to test. And on the other side, we're generating a lot of test code. And if we're looking at it, we've got a lot of code that we need to review, whether be it on the developer side, on the tester side. And we've got a lot of tests, a lot of code, because it's easy to generate both. And the question is, well, can we trust these tests? Can we trust them the way we used to do it? Now, I'm going to start saying right at the beginning, this is not an AI problem, although it may seem like it. But if you go back in time, like 2-3 years ago, before this AI thing entered our dreams, we had the same problems, meaning that we had a suite of tests. Usually we'd written it by ourselves or somebody else, and we would review it, and we would trust it in some way. We had some kind of algorithm in our head that says, this covers this thing, this is important, therefore kind of confident that this will work in production. This is not covered, this is not okay, but we can live with it. So we kind of created some kind of equation in our head and said, okay, we know what we have, we know what's pretty much covered, therefore we have a confidence to release or not release. The AI amplification, though, is that we have a lot more code. Some of it is generated completely by the Genie and not even reviewed because there's a lot of code to review. Some of it even reviewed by another Genie, which is a completely different problem. But in the end, we kind of left with the same decision that we had before. Like we have these things, these assets, this CI report, which is, let's say, green for our sake. Can we release with the same confidence that we want to? So this is the problem that we're having. Okay, so most people said they review and rewrite most of it, which is kind of bring me to and something that I told people to do when they're doing code reviews, when they're thinking about it. I'm doing that a lot to myself when I'm generating code. I ask people, when you review something and you don't like it, is it because it is wrong or is it because you would write it differently? Because everyone would write differently. Everyone does their own history, styles, idiosyncrasies. So I ask them, well, is it wrong or is it like you do it differently? And I find a lot of the code that I change in and refactor is I would write this differently. And is that okay? Would I leave it like that? That's another question. But obviously, the main problem is that we can't really review everything. So we don't actually know what happens when we don't know what we're reviewing. So I'm going to show you an example of what I call the Green Mirage. This is the Blue Mirage, an Autobot. But the Green Mirage, did videos about it and blogged about it. The Green Mirage is basically when you get a green CI report of your automation suite and it shows green. Okay, can you trust that green? And it really depends on what's inside. So I'm going to switch to code just a bit before we jump really into everything I prepared. But this is the beginning. An example, this is for my Miracle Bigger Better Bookstore app that I keep going back to. So this is like this is an ad review test. It creates the book, gets the book, check that the book was actually gotten correctly, adds the reviews, and checks that the review was added by the status, and then deletes the review. Is this a good test? Okay, so it does what we want. It does a bit extra checking for the book. It does have some kind of an assumption. If you go back to my flakiness webinar from last time, if you go back to my webinar last time, we talked about assumptions, and there's an assumption in the deletion here that if we delete the book, the review would go with it. But this is not the topic today. The question is this a good test for testing the ad review? And I'm going to just look at this line that checks the status code, and then you'd probably look at it and say, well, this is probably not enough to check that a review was actually done. Status code is probably not enough. Now, the problem is that a lot of the code does look like it. That's the problem. A lot of the code that's being generated is based on code that's been written by a lot of people, and a lot of people have a quality problem while writing tests. So that's not new. We try to raise the level, but if we're kind of generating stuff, it generates what it was based on, and what's out there, it's not perfect. So the assumption is that if we generate this, if we review it, we'll probably find out what's happening here, and that's okay, probably, right? But imagine you have 100 or 1,000 like this. So what happens is that you have a lot of tests that you probably don't review because you don't have time to review everything, and you kind of trust them to protect you, give you the confidence that you actually want. But if all of them are like that, what kind of confidence do you actually have? False confidence. And this is where the Mirage comes. So this is the Blue Mirage. Okay, so that is the problem. That is the risk. We'd like to be in a position where we trust our tests. Okay, actually, we'd like to do a couple more things. We'd like to use AI to generate our tests. This is not a bad thing, but we like them to generate what we want. So we'll get back to that in a minute, but you probably think, well, how I'm going to do a lot more than what it created for me? Well, there are a lot of options. If, for example, you check throwing around cases, right? So if a book doesn't exist, you can't add a review, right? Behavior, we'd like to see that it's working. Returns a 201, great. We saw that. It mirrors what I sent as an input. Each one of those will start making me more confident that this feature is working. If we go, but it's not really enough, because if you add a review, you probably will have an API that gets the reviews for the book. You want to see it's there. If you have an API that gets all the reviews, you want to see that the review in that list. Review for all the books. If you edit this review, you want to see that what you sent at the beginning, what you created, was changed. If you delete it, it's no longer there. But these are like the functional stuff that we probably think about like immediately. If I had a review, would it be there in a year? It's a good question, right? We kind of assume it would be, but we usually don't have some test that runs for a year and checks that. And a lot of things can happen in a year, right? If I add a review in New York, can you see it in London? You usually test that in the same room or same cloud. If I add a review, can somebody else see it? Can everyone see it? Can everyone who's allowed to can see it? Can you delete my review? If 10 of us add a review at the same time, what will happen? If 1,000,000 of us had reviewed them at the same time, will the server still be there? So the whole thing of adding a review can amount to a lot of things. It's not just a single API that does it work. And if we start thinking about this and say, okay, we want answers to all these questions, and we want confidence that these questions, as they were answered, really working, this would like please tell me that this is working the way I expect to. And we can do that, but we need to ask nicely. So there are principles. I know you're not used to seeing a lot of text from me, but I crammed all of it here. So one of the principles is always not the single API. It's very easy to think about like a developer dumps a document on your desk and you say, oh, these are the list that you need, the list of the APIs you need to test. Yes, but really, APIs are nice, single endpoints are nice. We probably want to, as you've seen, ask about the feature itself. The feature can grow, as you have seen with a couple of questions. What should you need, what should you ask? Well, first of all, we need to know, well, how we or somebody else expects it to work. We need to ask questions. Hopefully somebody will give us the answers. Another thing is how it runs, the context that it runs to. I'm going to allude to it, but I'm not going deep here. But any automation test that you probably run, from the unit test to something in a pre-production, whatever you run in staging, is an example that you look at the result of it and you say, if this works here, it will probably run in production this way. Okay, so if it's red, it's the same thing, right? If it failed, you say, this will probably fail in production, therefore we need to fix it. So we need to understand the context. Context sometimes is a single machine versus 1,000 clouds, 1,000 users. Like, can be anything. We can run the same API or the same set of APIs in different contexts. So we need to understand what we want to either simulate or copy if it's directly from production, and what will be the results of that. And once we do, we know what the expected result is. Another thing that you probably want to know is what's already covered. Like, you're going to generate a lot of tests every time. You probably don't want to generate more. It will cost you in different ways and tokens. Okay, so I'm going to go back into my code. And what I'm going to show you is how I develop these layers for this section here. I'm going to start with this test, because obviously this is not enough. So, and I'm going to show you how I used AI to help me both create these layers of confidence and trust. Okay, so what I did was iteratively think about how can I expand this and create a plan and create a prompt to generate the tests. That's basically it. In this case, the first case is, oh, this is not enough. What's missing here? Well, does the response body contain all the expected fields? Values match what was sent? Generated fields like ID, timestamp, whatever, in the right format. So things that are still at a single API test case, but they're missing in terms of, well, if we check those things, I'll be a lot more confident with my tests. So all these kind of tests, the Genie was very generous with these, and of course I asked it, well, generate those, and it did. Now pause for a minute. I'm not going to run through everything here, but I want you to understand what happened. So I reviewed what was missing. I reviewed the proposed test plan. And the proposed test plan basically what is the input and what is the expected output. And you can see that some of them are status codes and some of them are not. So, and then after I review this, I need to review or trust, depending on how trusty you are, the generated code. And I can tell you, like upfront, I did some refactoring on the generated code because, like I said, I wouldn't write it like this. Some of them I left, especially the names. But but you can see that a lot of them, once you have a test plan, it's very easy, in this case, to start comparing English to code. You can see that that's the response contains all the fields, and you can say, is this interesting for me? Maybe. Response values match input, so the ratings is 3, like I sent at the beginning. Where is it? In the book, it creates something with 3, I think. Oh, it's rating 3. It looks for the 3. Comment is comment, so what I put in, what I get out. And matches the authenticated user, a non-empty string, and timestamp is valid, and so on. So even at the single level API, I would like these things checked, and I could say, okay, this at least at this level, that's good. Then let's go up. No, we're not going up one level, but we're still staying in the single API. But we talk about the schema. So the schema is a protocol, a contract of how our service or API or endpoint is allowed to be talked to and what it returns a response. And there are things that, and what I'm going to show you are basically schema tests. And what I'm testing is really what is, no test ever asserted the response is exactly these fields. So the structure of the response, error responses, stuff like that. And you probably have those documented somewhere. And if you see the test, I'm going to jump to the test, generated test. You'll see that they look like, yes, they are like structure, but they actually operate the same API every time. But they check something else like this, and we have an ID which is string and title which is string. And if you look at, for example, a timestamp, it could be a string or it could be something else. You have another thing, a rating. Rating is an integer, but it also can be a string. So a schema tells you this is how I'm used to talk. And the question is, okay, if we got functional stuff, functional tests, do I need this? And the answer is probably yes. I'll give you a scenario where you probably want to. So let's say you expose your APIs, not just to one developer, but to all world. So you have a public API. And this, like I said, public API is a contract. You kind of swear by it. And if everybody and anybody and any bot anywhere can throw something in at your API, the question is, well, how confident are you that your API will respond properly? And the answer is, well, very low, right? You can't really expect everything. And you can't, if you can't expect it, you can't plan it, you can't generate it, you can't run it. And the schema is a sort of, okay, before the schema, if I checked the contract when I put, sorry, the rating, if I put 3, it returns 3. I can probably say that, yeah, he takes numbers and understands them, right? I can look at this as an example of testing the schema. But if I want to say that I need some bare minimum that if somebody talks to me, I understand how they're talking to me, and I respond in the same way according to the contract, the schema is really the bare minimum. And I will not check that if I send 3, I got 3. I will check that I've got in the response these fields, and they are of these types. And I've lists where lists should be, or empty lists where they should be. So structure or shape of the response. And is that enough? No, but it's a layer of confidence. This is what we're going to talk about today, right? Layers of adding that says, at least if somebody speaks to me outside the contract, I know how to react at the bare minimum, which in regular functional tests, which probably use happy paths, smiley paths, and stuff like that, you probably wouldn't go there. So this kind of a layer of contract of the interface that you're talking to, but it's run exactly as regular tests. Okay, so we've done the single API, both in schema, but yeah, I would probably want to do at the feature level. So here I want to just create a prompt. I have a book API store, and this is like I'm doing this incrementally, like I said. There's a feature, a review. These are the endpoints that I have. This is the way we do authorization, authentication, write a test plan for the full add review feature. As you will see immediately in the resulting plan, if this is full, yeah, we can debate about that. But of course, anything can be tweaked and you can go deeper and wider and so on. But this is an example. So what do we have here? So examples like what we didn't test yet is that the review appears in the list reviews, the other APIs. Edits are reflected in listing endpoints. Deletes actually remove the data. So all kinds of combination. I gave the Mr. Genie all the APIs that I have, that it knows about. and he can play with it. Now, where's the prompt? So where does this come from? It can come from us. It can come from a coding agent that sits inside the code repo and understands it. Documentation can come from all different. So remember the how do you know that it works? All the how do you know, the context goes into bringing it in. Otherwise, the plan would not cover anything or anything that we're interested in. So what we get here is create review, get the review, multiple reviews in the same book, edit a review, see that it appears, the new data appears, delete the reviews, it's gone from both lists, error cases. A review on book A does not appear in book B's review list. Also interesting. How deep and how wide is this really depends on a lot of things. It starts with how much information you get to the AI when you're planning this. The more I said that, and I'm gonna keep saying this, the more your application or your feature resembles something that is not unique, it's general. In our case, it's very general. Like this is a CRUD application with books and reviews. Like let's say in Claude, in my case, was not surprised here by much. The more your application is like other applications, you will get probably the responses that you want and will be fit to what you're trying to run. The more unique your application, the guesses by Mr. Genie will be guesses, and you'll have to tweak them, and you'll say, oh, this is not okay, this is okay, and so on. But once I got this, you can generate those. And these are okay, really, and it's really my responsibility to review everything. So that's a layer of the feature, and of course, this is not everything, but it could be a lot of things. We can talk about the feature itself, but it's not really important. It's books, really. I do want to go another level and another layer. And remember, I told you that one of the things that you probably want to know is how it's built. Why is that important? Okay, so let me show you how it's built. Where's my server? Okay, so this is the code for adding the review. Okay, so this is the create review function that sits behind the API. And you can see a couple of things. First of all, these things here are validation of whatever. If something was not there, the user ID was not there, it will get a 401, all kinds of things. But then you will see that it does this. And this is a call to another API, which calls it's called the moderate API, and basically it checks that what you put into your review, although valid because it went through all the validation, is nice enough to post to whatever criterion. It could be approved, it could be not available, it could be that there's a server, it could be that there was a timeout or unavailable, all kinds of things. But in our case, and for our purpose, it's a dependency. How would I know there's a dependency here? I need to ask. I need to know that there is a dependency, because if everything was inside here, there wouldn't be any problem like the moderation service doesn't answer because there won't be any moderation service. But if there is some kind of behavior in my service here that I would like to make sure it works. So in unit testing world, we would probably think like this is mocking, right? We have a dependency, we mock it, and so on. And this is true, but usually we kind of skip the fact that we mock in order to see that our code works. And basically, this is what we're trying to do this, but in another integration level, right? If the other API, the dependent API, plays tricks on us, how does it look from the outside? So this is what it looks like. I can knowing this, I can go here and tell Mr. Genie, well, this is the API. It calls an external moderation service. This is what I expect to see. If it's approved, I want to see a 201. If it returns a 500, like internal error, I want to see a 503. Not a good requirement, but let's play with that. I'm not going to mock this, but I'm going to program it. So this is a moderation service. In my case, could be programmed to when somebody calls you, you would answer this, and then you reset to the default behavior. So you can mock, of course, APIs. You can program them. You can do a lot of things with them. Set them up, configure them. In this case, my moderation service is programmable, and I asked for a test plan. So what happens for each mode of moderation failure and approval? That the system goes back to normal. It accepts another review after failure. Okay, and all the validation cases mentioned at the top. So did that. Got a plan. Looked okay. You see that there's a lot of, well, what does it invent here? What does it add to the thing? Well, so far it hasn't done a lot because I haven't told it to like go wild. If you've seen my planning webinar, I showed that the more you ask for more elaborate cases, you will get a list of those. So it really depends on how focused your question is. And what I'm showing you here is like I said, it's incremental. I'm going to say, well, we tested all this until now. What haven't we tested yet? So we got this, and of course we got the tests, and it creates the tests and it runs the tests, which is very nice, and that they actually pass and so on. And now I've got another layer that tells me that the code inside it, my code, okay, not moderation service, is somebody else's code. My code reacts to problems or internal behavior in a way that I expect to see from the outside, which is nice. If it was like black box completely, I wouldn't know it's there. I wouldn't try to do this. I wouldn't know how to do this. This is another thing where you want to know how things are built rather than considering them black boxes. Okay, I mentioned that 10 people doing it at the same time. Concurrency, you probably want that. Concurrency means that we have to design some kind of experiment, or our test needs to be in such a way that we say, if these things happens, this is what I expect to see. How do I know what it's expected to see? Again, we need to ask. So we need to know what to expect, and I need to expect that all of them got a 201, and if I get everything, they will be the way exactly I wanted them to be. Ratings and comments match what I sent. So this is a very small thing. I can really go wild there and say, well, test me all kinds of things. Create a concurrency test for all these things, and it did. But the interesting thing, and this is again coming back to, would I write it this way? So what it does, basically, you have all the tests here, and for each time it runs 10 concurrent threads and run it. So, but it does this for test all concurrent submissions, reviews, duplicate reviews check, each review has correct data. And while I was thinking about running this for 10 concurrent tests, you would probably think, well, run it 10 times for 10 concurrent users, then check everything, which is kind of falls into the bucket of I would write this differently. It's not completely wrong, but this is kind of wouldn't say exactly a waste of tests, but it could be a waste of time. Depends on how long it runs, how big the setup is. It could have an effect. So this is again a reminder of, even if you kind of trust your Genie to do whatever you want it to do, yeah, it might go in a different way that you thought. So reviewing the tests still sucks, but we can't trust it completely. And I left it like this because I didn't want to. I wanted to show you real things that happen. Okay, I want the next example is about load testing, and I mentioned that I give like 1 million people add a review at the same time. What will happen? And we kind of veering into the world of non-functional requirements, non-functional testing. I don't really like this. I did a webinar like a while ago about non-functional testing because it is functional. It's just a question of how the context will work. Specifically for load testing, I use the Locust, which is a Python variant of JMeter, stuff like that. The tool itself does not really matter, but the process of what you actually want to do does matter. So usually with load testing, what will happen is that you don't know what you actually need. So you kind of test. You kind of create some kind of load and check for things. And as long as those things check out, behave as you expect them, it's okay. And then you raise the load and see if things are okay. And when things start not to be okay, you'll say, well, the former load that we test, this would be our standard. This would be our assertion we can trust. And that's why usually when you run load tests, you're really in exploring mode. You want to learn what's happening. And at the end of this process, you can say, okay, we want to make sure that at least for 20,000 concurrent users, this still works. For other things, we don't commit and we don't test. So you can create them. And like I did that, 100 concurrent users, so on. This is the locust file. You can find it on the GitHub repo if you want to run it. And you see this is like a runner. It's not an asserter. If you want to do this, you probably run this and then assert into results. It gives you confidence that at least these things still work. And of course, this can be expanded not just for load, for anything that we want to take it to, not for APIs, but accessibility things. Okay, so accessibility, you think about a UI, and there's probably a list of things that you can get a list of all the violations in a page, and you probably want them all fixed, but you can't do it today. So you can track like the bare minimum of how much or how many things are going. Example. The more you ask, the more you think about it, you can create better plans and you can generate more. Two more things, security. So this has authentication, authorization, stuff like that. I used to, well, not used to. Before AI, I would see authentication and authorization tests separate from functional tests in test plans. Like first check that this works and then check that it works for admins or regular users. The interesting thing that when I started using AI to generate test plans, I saw that these tend to include right authentication and authorization right from the start, which I need. I think that that's the way it should be. It's like another context of your function. So plan these things across user access. Users can delete their own reviews, but oh, by the way, you need a post, put, and delete. Require token, get doesn't. Only the reviewer can edit or delete the review, and you create a plan for that. And you can present this plan as much as you want, and then you create a test suite for these things, which is another layer. Final thing I want to show you is that again, I said non-functional stuff. I added reliability here, and this I did not as a check this for me, but more like, well, what else do I what have I missed? What would you test to verifying long-term reliability? The scenarios can't be covered with simple HTTP calls. List them because I'm going to show you the results that I got. This requires some setup in order to run them. So the plan I got, data persistence after restart, failover consistency, backup and restore, timestamp accuracy, deterministic order of restart. Like these are good cases. But in order to run them, I'll need something that I don't have today, ability to backup and restore. Ability to backup and restore automatically. Check that the order was deterministic. Cut off and then restart things. So these can be generated into tests if I give my agent enough information on how to do this. But this is already a good idea of how to expand my planning. And again, what I'm looking for, and I can decide, like I could have stopped anywhere. What is the layer of how many layers is enough for me? What have I not tested yet? I need that much like test planning. I need to ask the questions. The good thing is that if I ask good questions, I get good enough answers usually. And if I did this incrementally, as you've seen here, and at the end, you can take all the increments that I did and add them all into a single prompt, really, which maybe may not be copyable to other features, but it could be like a good template to start from. It could be like another way to start incrementally to go through things. But it can be modified by you or by another genie to fit other tests as well. And this is like incremental, not just in one way, like we did until now, but you can move whatever you found until now and move from there for another feature, which is kind of nice. Again, you need to review. All the things I showed you until now fit in a page usually, not the code, but the plans, which makes it easy for me to review. This kind of thing already starts to annoy me. Annoy as in either I'll not review everything, or I'll not review, I'll just scan it and say it looks okay, or maybe I'll say, it's okay. It looked okay. The first part looks okay, probably the rest are. And this is like a risk I'm taking. And this is something that we need to remember, like we need to review. If we can't review it because we're humans and we're not like text readers, we're going to introduce risk into our quality process, obviously. So I talked about the principles and the steps, and it really is the more experience you have, you can ask better questions. The cool thing is that, and this is something that I showed in the planning webinar, if you can ask minimal questions, you get to a step here with a lot of answers that you wouldn't get from before. So if you had to depend on organization level knowledge, like the experts, the elders of the company, and of course, a lot of documentation and history and the automation itself to collect data from, you have another source that will help you plan and help you generate a lot more tests. And remember, we want to avoid the Green Mirage. We want tests that we need to, we can trust. But in order to do this, we need to review, and this is like our part, right? So again, know how it's built, know how it runs, know how it actually works or needs to work, and know what's tested, because you don't want to generate everything. And you saw the incremental thing, kind of knowing and going through what's already built. And it's not just me, it's the bot itself, the code agent that it is. Okay, another poll. So this is a question of where you spend your time on tests. Debugging them, figuring out what actually happens, if things are flaky or not, spending time on what we talked about today, which is writing or generating tests that you actually want to feel confident about, or the maintenance itself, like running after the API composition. Okay, so there's a nice spread about half of them was maintenance, maintaining the test of the changes. The rest was spread around the other options, which is interesting. Okay, so what you saw today is part of the API Masterclass. The Tactician coming out on October 5th. So it has 4 modules: data, assertions, debugging, testing. You saw part of the assertions today. This is live with me, 4 sessions with exercises on-hands testing, really digging deep into these ideas and making you a better, I think, tester, better automator, better tactician. So it starts on October 5th, for runs for 4 weeks. $399 early bird that ends through July 31st. After that, the price goes up. If you're interested in taking your skills up and you liked what you saw here and you want to do some practice on it, that would be a good place. There's a lot of things that I do there that doesn't appear in any course out there. So I recommend, of course, coming. This is the QR code for the link for the page. You have a lot of information about more details about there, and you can register there. I want to thank you again for coming. Have a nice rest of the day. Bye bye.